orbital.
The chamber pressure looks good. Toggling up. Roger roll, Atlantic.
Water towers can fly! Yes!
Tango Delta nominal.
Flight SE off. Bring in SE off. Yikes. You bet. Concur. We don't need any more of these.
All right, what's up, everybody? Good evening, good morning, wherever around the world you're watching from. I'm Jack Beyer, host and video editor, producer, photographer, whatever you want to call me for NASASpaceflight. Let me get a 5x5 in chat so I can know you can hear us fine. But you are looking at a rocket at LC-39A, Kennedy Space Center. And we are ready for the launch of IXPE. But it's not just me that's going to be talking tonight. I'm also joined by Chris Gebhardt. What's up, Chris Gebhardt?
What is up, Jack Beyer? I am doing just great here on the Space Coast. It's the sun is not up, and there's a rocket on the launch pad, so it feels normal for this week.
Yeah, it checks out, right? And you are the assistant managing editor for NASASpaceflight, and you will be operating the camera tonight, right? Is that true, or is Thomas going to be operating tonight?
Thomas is for
Right,
tonight.
cool.
Yes.
And then next up in the field, we have Julia Bergeron. What's up, Julia?
Why, hello, Jack, and hello, everybody. As Chris said, it is dark. There's a rocket in front of us, a VAB to the left of us, and I'm excited for IXPE.
Yay, satellites. And observatories.
Bingo!
Well, thank you for joining us, Julia. You can follow Julia there. You can see her Twitter handle on screen. She's a fleet chaser extraordinaire, an excellent photographer, so be sure if you don't follow Julia, give her a follow. And next up, we've got Thomas Berghardt. What's up, Thomas? You on comms?
I am on comms. How's it going, Jack? Good to be back at the press site for yet another launch.
It feels like you guys were just there yesterday, or within the last 24 to 36 hours.
Yeah, time is a flat circle, Jack. We're not sure what time it is or anything, but shortly ago we were just a couple miles south of here, and now we're back here at the normal KSC press site because we're back at 39A.
Can confirm time is a flat circle. Cool. And then in the background, of course, we've got Michael Baylor pulling the levers, pushing the buttons, doing all the steampunk things that are necessary to keep an operation like this running smoothly. So thank you to Michael for doing that always. So don't forget, guys, if you've watched our streams, you know this by now, but if you don't remember, or if you're new, hey, if you're new, hello, first off. Second off, this is, we do an interactive kind of thing here. So if you have any questions, what you can do is you can @NASASpaceflight in chat, and that will help your question pop up in some nifty software that Michael wrote that we like to call the panel. So yeah, if you have any questions, please type them into chat, and we will be going around the horn here and answering your questions while we wait for launch. Currently, about 40 minutes to go, right? And what kind of window were we looking at today? Who wants to take that one?
Yeah. So there is a 90-minute launch window tonight for IXPE. So it stretches from 1 a.m. local to 2:30 a.m. local, or 0600 UTC to 0730 UTC. The 90-minute launch window is driven mainly by the sun. So IXPE, once it pops off the top of the Falcon 9, it's a very, very small spacecraft. The batteries are very small, so it needs to get power positive very, very quickly. So it needs to be in orbital daylight when it comes off the top of the rocket so that its solar panels can deploy and it can get power positive very quickly. And in order to do that, that dictates a 90-minute launch window that opens at 1 a.m. local time here on the ground, so that when they're over Africa and it's time for payload separation, you are more or less midday, early sunrise, so you've got a lot of sun that you're going to be tracking over in your equatorial orbit, which is where IXPE is going today. So that dictates our launch time tonight. And there's a lot of quiet on the line there.
I think, Jack, you hit the wrong button.
Yep, talking while muted. Sure. I was just going to say thank you to Mars Labs for becoming a Capcom member. They came in at Capcom level, so they get Discord access, and they get other various member perks like the chat emoji and the preview videos. So thank you to our new member, Mars Labs, and thank you to all our current members. And note to self, don't talk Well, muted. Let's see. I'm gonna bring some questions into chat here. But first off, what booster is this? I'm just gonna ask some questions that I want to know the answer to right off the bat.
Well, Jack, this is booster 1061, and this will be its 5th flight. This one started with Crew 1, and then we had a second crew mission with Crew 2, moved on to SXM-8 and CRS-23, and now we are on to IXPE. So this one's seen a lot of action for a 5th flight.
It sure has. This is the worm booster, right?
No,
The worm booster is 1058.
Okay.
The worm booster is you almost can't see the worm actually anymore. So
that's kind of the cool part, though. Like, it's worn. But this isn't this booster. I'm a dummy.
Nope.
Let's
You're
see,
not a dummy, but
we kind of have a meta question here from John. Which press site is better?
Ooh.
Depends on the inclination and the rocket.
Right, yeah, that's what I would say. It depends on where the rocket's going. This press site actually here at near the Launch Complex 39 press site, which is right next to the VAB, is good for 39A. It's also good for the Atlases from 41. But since it was primarily a Space Force mission, we were over on the Space Force station side, and we had a pretty good view of Atlas the other night. I was a pretty big fan of that, especially if there's a launch from 40, one of those Falcon 9s. You don't want to be up here at this press site. You want it to be down farther south and closer to the rocket. So yeah, like I said, it depends on the launch.
Good stuff. And Manic Universe is asking, hi, greetings from Poland. What platform is the Falcon 9 going to land on today? What drone ship are they using? It's not going to do an RTLS, right? It's going to a drone ship?
you are correct. It is going to a drone ship. It is going to just read the instructions. Support ship Doug is currently with Just Read the Instructions, and that is who towed it out of port. And we also have support ship Bob with fairing duty. So respectively, we are at about 635 kilometers, almost due east for Just Read the Instructions. Add another 130 or so kilometers east for the fairing recovery.
Cool deal.
And Thomas, I know this is something that you're really that you've been talking a lot about, because IXPE is very small, right? Normally we hear downrange drone ship landing and we're like, oh my gosh, it must be a 6 metric ton satellite inside that thing, 6,000 kilogram satellite. Not true. IXPE is only 325 kilograms. It's not even half a metric ton. It's barely over a third of a metric ton. It's the lightest payload the Falcon 9 has ever launched. It's ridiculously small. Fully deployed, it's only 5.1 meters long and 1.1 meters wide. The payload, the wingspan of the solar arrays are only 2.7. So why is it going to a drone ship? Why, if it's not even a third of a metric ton, Thomas, how come the first stage can't come back?
Yeah, this goes into where this spacecraft is actually going. And of course, at first glance, it's going to low Earth orbit, which should scream even more. Really light spacecraft, low Earth orbit. This has got return to launch site written all over it. But the fact of the matter is, it's not going to just any low Earth orbit. It needs a very specific one, and that is near equatorial, which means instead of orbiting at some mid-inclination like most spacecraft launched from Kennedy Space Center do, this spacecraft has to launch from Kennedy and then conduct another maneuver on the way up so that it will be orbiting over the equator. And I'm going to go to Chris on the science of why the spacecraft actually needs that. But in order to get there, Falcon 9 has to do this little thing called a plane change maneuver. And what's going to happen is the first stage, once it drops off the upper stage and the first stage will go land on the drone ship, the reason it's doing that is to give the second stage extra propellant so that once it reaches its initial orbit, it can conduct another burn when it flies over the equator to tilt the orbit from its 28.5 degree inclination that it'll start with, simply from launching from the Kennedy Space Center, all the way down to 0.2 degrees inclination. So very, very close to a perfectly equatorial orbit. And that's going to enhance the science capabilities that the spacecraft will actually have once it's ready to go.
Yes, and to that, one of the main reasons that it is going to an equatorial orbit, there are several. But the main ones are that is the area where you spend the least amount of time in the Van Allen radiation belts, which helps with this particular mission's observations since you can't go above them. And the reason we're not going above it, it's only a 600 kilometer plus or minus 15 kilometer orbit. So it's a little bit higher than the Hubble Space Telescope, a little bit higher than the Inspiration 4 crew mission went in that regard. But the Chandra X-ray Observatory, which is the most famous X-ray observatory that we have up there, is in a 14,000 by 136,000 kilometer orbit inclined 76 degrees to the equator. IXPE is not going anywhere close to that, and that is largely because while it's small, they didn't need a rocket to throw it to this great orbit like Chandra's in. They can do it very well within low Earth orbit at 600 kilometers at 0 degrees inclination for the mission objectives. The other reason it really works out is because the primary ground station that IXPE will be transmitting all of its data back down through is it's part of the Italian Space Agency's contribution to this mission. So IXPE is a joint mission from NASA and the Italian Space Agency, and the Italian Space Agency is providing the Malindi tracking station off the coast of Kenya, and that is at equatorial latitude. So putting the vehicle in an equatorial orbit ensures that every orbit you're passing over your ground station, so you can downlink and download and uplink every single time you come over it on every single orbit. So those are the primary reasons why IXPE is going to the orbit and the inclination that it is.
Also,
I love it when you guys answer questions that we have in the question queue without me even having to ask them. We had a question about this exact thing from Ryan Jr. saying, "Can you explain the orbital plane change that will be performed?" And here you go. You can see it even. Michael has a nifty graphic from Flight Club up there on the screen as well, showing how it's initial inclination and then what the inclination looks like when it's equatorialized. That's probably an incorrect way to say that, but after the plane change, once it's equatorial, you can see the two burns there, right there on the screen.
And it's worth noting how propellant heavy a maneuver like this is, because it's a full minute long burn of the already incredibly overpowered Falcon 9 upper stage. It still takes a full minute firing the Merlin vacuum engine to change the inclination by that much. That's a lot of propellant that it has to go through in that amount of time. So you can really see how propellant hungry these inclination and plane change maneuvers really are, which is why we don't do them and why we typically launch right into the inclination we want to go to. However, the lowest inclination you can launch into during the initial phases of liftoff to get into your preliminary orbit is based on the latitude that you're on. So 28.5 degrees latitude, which is what Kennedy Space Center is at, is the lowest inclination you can initially get into, and then you have to change it once you're already in orbit.
And it's worth making some comparisons here because getting into equatorial orbits can be particularly useful for several types of missions. In fact, the most recent mission that we saw here at the Space Coast, that Atlas V launch, also went to an equatorial orbit. Of course, it went to geosynchronous orbit, which is much higher, and actually, from orbital mechanics, if you conduct the plane change maneuver at a much higher altitude, it actually takes less energy, so there was some sneaky physics going on there. But of course, this mission only going to low Earth orbit. Other companies that offer very mobile launch systems, places that can launch from less built-up launch ranges than the Kennedy Space Center, or operators that operate air-launched vehicles that can take off in an airplane and then go fly to whatever launch, drop zone that they want to work with, often tout that as a way to get to low inclination orbits, which is true. But SpaceX is showing another way that you can also get there is by simply having a big enough rocket that it has so much performance that it can make up for the inclination change and just do a burn like Falcon 9's doing. So obviously there's trade-offs there, but that's another just something interesting to talk about with regards to how SpaceX is going to accomplish this mission.
Yeah, that makes sense. If you've ever played Kerbal Space Program and accepted a contract for a mission that has a big plane change like that, oh boy, you better have the Delta V. And I know, obviously, Kerbal Space Program's a game versus real life, but some of the lessons you learn ring true, and changing your inclination is definitely propellant expensive. But like you said, curiously enough, the higher altitude you do it at, the less expensive it is. That's interesting always to me. Orbital mechanics. Let's see, really quick, we've got a couple super chats coming in. Thank you to everybody for the support. Connor G with the $5. They say SN8 last year on my birthday and Falcon 9 launch this year. Congrats, buddy. Happy birthday. Moldy Space, thank you for the support. Always chiming in with Moldy Space. Or Moldy Space is always chiming in with support, I should rather say. They say second most exciting observatory to hopefully launch this year. And
Yeah.
as always, Thomas Fan Club. That is
What's
a
up,
James
Moldy
Webb
Space?
reference, right?
Yeah, I'm going to assume so. And which, by the way, is exactly 2 weeks from today, by the way. In case those pre-launch jitters had died down at all, just
Oh,
a
God.
reminder that that's 2 weeks away. Anyway,
Oh, God.
continue.
Oh god, now I'm sweating and panicking and crying and shaking. Please fly true, Ariane 6.
December 22nd. It's going to be an interesting morning and day.
Uh-huh.
Oh god. Okay, before I start
But IXPE,
breaking out in
yes.
hives over here, IXPE, Roy Tyson, thank you for the support. They say, do you think there will be a day that SpaceX will land and refly a booster without refurb? Wasn't that the goal?
Without, like, at all? Like, I don't know. It depends on what you define the line as no refurb. I mean,
To me, the spirit of the question is land it and then fuel it back up and fly it again without refurb. That would be how I would interpret that. Your mileage may vary.
I don't think that will ever happen with the Falcon 9s.
right. Yeah.
I think you want to see that. Wait for Starship. I don't think it'll ever happen with the Falcon 9s, even though you are right. That was the goal.
Yeah, I mean, you can see here shortfall of gravitas on the right with the booster from, what was that, a Starlink mission?
Yep.
Yeah.
Yeah, and it's, the booster is still on the drone ship. The drone ship came in, what was that, yesterday, I want to say?
Yeah.
Yesterday morning.
And
Yeah,
it's-
we
it's-
actually did see it with our own eyes before it got to the dock. It
Yeah.
was there.
Nice. Yeah, I saw some cool photos, and some fog, I believe, was at issue. But point being, currently we're at a stage where the booster takes a little bit of time to even just offload from the drone ship, safe, get the legs, folded up and everything, and then truck the booster over to the HIF or VIF or wherever they are going to do refurbishment on it. So we're a little bit of ways away from that. But yeah, I think like you said, Chris, Starship is what to look for in terms of reuse that is that rapid.
Indeed. And just before we go to the next question, we can see here with our Mark 1 eyeball, as Doss would say, that we have frosty Falcon 9 starting and some vapors forming on the first stage. Propellant load has been underway for about 10 minutes at this point, with RP1 kerosene intensified liquid oxygen flowing into stage 1 and RP1 kerosene flowing into stage 2. Coming up here at about the 20-minute, 20-second mark in the countdown, we will have a big vent from the transporter erector, which is them purging the propellant lines. RP1 kerosene load into stage 2 will wrap up about the T-minus 22-minute mark, and then they'll purge the erector lines and the propellant lines and get ready for liquid oxygen loading to the second stage, which will pick up at about the T-minus 16-minute mark. So just a quick overview of where we are in our countdown as we march toward a liftoff at 1 a.m. local time, 0600 UTC, which is the opening of our 90-minute launch window tonight.
Sure enough, we're just under 5 minutes away from that legendary T-minus 20-minute vent, so we'll keep our eyes open for that vent to happen, as you said, as they purge the various lines on the rector there. Let's see, really quick, Rodrigo Valdez, thank you so much for the support. They say, hey, from El Paso. This is kind of a big question. What would you guys consider your favorite rocket of all time, and why? I mean, Chris, why is it shuttle? I guess.
Yeah, I was going to say, I know Chris is it.
Why is it shuttle? It is shuttle. You know what? It's almost indescribable. Watching a shuttle launch was just like an exercise in that looks amazing and it looks like it shouldn't work, and it did, and it was just gorgeous every time. Like just the way it rolled and all worked together. But I will say honestly though, for me it's because almost everything that we see today, whether it's in the Falcon 9s or Starship or, the reuse that ESA is headed for, Blue Origin, all of these other companies that are embracing reusability in that regard, that's all where it started, was with the shuttle. And you might not recognize it, but it's there, right? Like, I mean, there's not a lot of visual similarity between a Falcon 9 first stage and a shuttle orbiter, except for their color scheme. But, you know, getting the boosters back, getting capsules back, getting second stages back, getting all those things, that's all where it started, and the technology that laid the groundwork for where we are today. So that's the answer for me.
Sure enough. Thomas, why is it Ares 1 for you?
See, Ares 1 I usually say is one of my favorites, but if I had to pick my favorite rocket of all time, it's actually not Ares 1. There's just something holding me back about picking a rocket that never actually went to orbit. But my favorite rocket of all time is actually Delta II, because I like watching the super dramatic 9-solid configuration lifting off and emerging from a cloud of smoke and dust, and I think that was the coolest thing ever. And so I'm going to say Delta II is actually my favorite rocket just because of how it looks when it launches.
Nice, not a bad choice. Chris, I'm going to need you to, while you're muted, talk to Thomas and ask him a question only he would know, just to ensure Thomas is the real Thomas and he's not been replaced by some sort of hyper-realistic cyborg.
Oh dear, he's wearing a baseball hat backwards and he has a beard. He may have been replaced.
And Julia, what is your favorite rocket of all time?
Wow, you don't even have a guess. I'm going to also go with shuttle. I'm going to be the sentimental one here, but that is the rocket of my childhood. And that is what gave me the passion to do what I'm doing now. So,
Nice.
shuttle, it's pretty. I really wish I got to see it launch, but it's very much a part of what inspired me.
Yeah, I do apologize for not having a guess. I figured the joke was tired at that point, but no,
It's
shuttle
okay.
is, as much grief as I give the shuttle sometimes for being awful in various ways. It was absolutely a magnificent machine and a triumph of engineering. And you know what? I'm going to say it's my favorite as well.
It was definitely a
Good
good.
choice.
It's high up there on my list before the shuttle huggers come attack me. To be very clear, big shuttle fan over here too.
Thomas
trying to make
suddenly
sure-
feeling insecure about his job.
Yeah, exactly. Thomas
Dare
making
I
sure
say?
he's hedging in case Chris B.
I
is
didn't even pick the shuttle-derived vehicle that's Ares 1, so what am I doing?
I don't know these people around me today. So if I could pick a modern day, I would pick the sexy Electron. Just putting that out there, y'all.
Nice.
I'm a fan.
It's a cool looking rocket. I can't fault you for that. Let's see. Don't forget, ask your questions at NASASpaceflight. A couple more super chats just came in. Celadon Hair Extraordinaire, thank you so much for the very generous support in New Zealand dollars. They say, I haven't had a super chat in a little while, but I've managed to snag myself the first long-term job I've had in a hot minute, so I finally feel all right with splurging money on supers again. Thanks for the great coverage as always. Well, thank you, Celadon Hair Extraordinaire. It's one of those names we see pop up a lot, and it's a fancy name, so it's hard to forget. But
Thank
seriously,
you.
thank you for the support, and congratulations on the new job.
And there is our big vent right on time. 20 minutes, 25 seconds, as expected. So this is just them purging the transporter erector lines, getting everything nice and inert so there isn't an accidental ignition source left within it when our liquid oxygen begins flowing into the second stage here in about 4 minutes' time.
Sure enough, proceeding into the count smoothly, just under 20 minutes to go at this point. Timothy Devine, thank you for the support, buddy. Andrew Reyna, thank you for the support. They say, where does, of course I still love you, drone ship drop off load for launches from the West Coast? That is Port of LA. That is a Port of LA type situation. Very cool to see with your own eyes if you get the chance. Let's see. I Best, thank you for becoming a pad rat. Corey, thank you for becoming a red team member. Thank you to all of our members. We got 2 new ones right there. What's up, guys? And Mark Lamb, thank you for the support. They say, this is like rubbing salt in the wound after the launch the other day when we were talking about Titan 4. They say, did any of you attend a Titan 4 launch, and how does that compare with some of the other launches that you've seen? That hurts. That hurts, Mark Lamb. I feel like you're calling me out specifically on that one. No, I haven't seen a Titan 4 launch. Anybody else want to take that?
Jack, I haven't seen it either, so I'll be there with you.
So close up, I saw one. This is before my media days because they retired before I was a professional media. But I saw one from up close, from the Cape, and it blew up about 30 seconds into flight. So
That's awesome.
I've seen it. Yes, and I mean, I've also seen others from farther away, but that the only one I saw up close blew up about 30 seconds into flight. Yeah.
Were the Titan IV solids related to shuttle SRBs, or just similar shaped and sized?
Similar shape. They were nowhere near as powerful, even though they burned for about the same amount of time, because that's based primarily on the motor's diameter instead of, and a bit on the propellant grain and how it's cast. But no, they weren't anywhere near as powerful as the shuttle and SLS solid rocket motors. And I do not believe they were made by. I don't believe the same company made them either. I don't believe I need to go check, but I don't believe Thiokol, which is what ATK Northrop Grumman was back then. I don't believe they made the boosters for the Titans. I think that was somebody else. I'll have to go verify who that was, but
Got it.
yeah, similar in terms of they were segmented. They had to have seals. You know, there's only so much variation in solid rocket motor propellant that you can have, but similarities really ended there.
Let's see. They were manufactured by Chemical Systems Division of United Aircraft, later United Technologies Corporation.
There we go.
UA-120 solid rocket motors.
There we go. Not Thiokol.
I miss ATK. If you're ever in Utah driving through Promontory, go check out the ATK, now I suppose Northrop Grumman Rocket Garden.
Yeah.
And also the Golden Spike, which is like right near there from the Transcontinental Railroad. They're right next to each other, kind of wild.
Yeah. Their test facility is right outside of Promontory. Yep.
Let's see, some questions from our viewers. Here's a sort of a general one that's kind of interesting. Bruce Fisher asking, what is the Q in max Q short for?
The Q is the letter we use for the variable for dynamic pressure, which is basically a pressure parameter that changes with velocity and air density. So when we talk about max Q, which is a point during every rocket's ascent to orbit that is important, max Q is basically the maximum amount of air pressure on the vehicle during ascent. And because of the two different factors that affect it, as you get higher and faster, your velocity is increasing, and that is increasing your dynamic pressure. However, as you get higher, you get into thinner and thinner air, and the density is lower, and thus that is decreasing your dynamic pressure. So at some point during the flight, those two changing parameters result in the dynamic pressure, initially increasing, reaching a maximum, and then beyond that decreasing because the air is so thin. And that point where it is at its maximum is max Q. Now, if you were to fly a rocket at full thrust the whole time, there would be some natural point of max Q. However, that maximum dynamic pressure might be so high that it would legitimately damage your rocket or even cause a failure. And so for most rockets, especially Falcon 9, the first stage engines throttle down for max Q because they'll actually stay at the maximum Q level that they can tolerate for a few seconds by throttling the engines down a bit. And that reduces what the maximum dynamic pressure you actually reach is. But that is what Q stands for, dynamic pressure.
And you mentioned, Thomas, that most rockets do throttle down. The Antares rocket from Northrop Grumman, and I'm using Northrop Grumman here very specifically, the Antares rocket, which is the liquid-fueled first stage, does not throttle down during max Q. And they actually changed it from throttling down to not throttle down to get extra performance. Because if you don't throttle your engines down, that's more thrust, that's more performance and energy you can put into the overall vehicle and getting your payload to orbit. But I bring up Northrop Grumman very specifically because throttling a liquid-fueled engine is very easy. You just lower the throttle, right? I mean, oversimplifying that, but you get the idea, right? Ease off the gas pedal, basically. But you can actually throttle a solid rocket motor down when you go through max Q. And in fact, shuttle solid rockets and the SLS solid rockets are specifically designed in their burn pattern to reduce their thrust as the vehicle goes through max Q to assist the liquid engines in the vehicle overall in making sure that the dynamic pressure doesn't breach the operational limit. So you can do this with both liquid and solid propellant vehicles as well.
Yet another piece of math related to rockets that I am so glad that I do not have to do. You can see views of the drone ship here, and also views of the fairing, and views of Falcon 9 and 39A. So we've got the whole gambit here. Getting ready, 13 minutes, just under 14 minutes to go until launch. Here's some good question. Can this launch be seen up the U.S. coast? It's going basically straight east, huh?
Yeah, basically, if you're in Florida and the skies are clear, you have a shot. Bahamas, the Caribbean, you have a shot as well of seeing this. To our friends in Georgia and the Carolinas and up the eastern seaboard, negative. Not tonight. Maybe southern extreme portions of Georgia, but not really.
Yep, it matters which way the rocket's going, and today it's not in your favor if you are not in Florida. Sorry, y'all. But that's why you have us.
Indeed.
Let's see, how many more launches does SpaceX have planned for this year?
At least 2. There are 2 more Falcon 9 slated for the Space Coast this year, one of which will be the Turksat 5B communications satellite from Pad 40. And then back here at 39A later this month will be the CRS-24 resupply mission to the International Space Station. Those are the 2 that are definitely manifested. There is potential, as usual, for a random Starlink mission to appear, either from here in Florida or over California at Vandenberg. So that's a possibility. But that should do it for SpaceX to round out the year. Those 2, and maybe if a Starlink shows up.
Yeah, and I think just based on where these missions are, Turksat is on the 18th, CRS-23 is on the
21st.
That probably realistically means that if a Starlink were going to happen out of here, it would be like the 30th or the 31st, just based on the amount of time it takes them to turn 40 and 39A around between flights. So Vandy would be my guess if there's a Starlink, but I really wouldn't.
Vandy has a higher chance.
Yeah, we'll see. Yeah.
Cool. And we are going to have a Starlink from Vandy on, what is it, the 17th?
Oh, that must have been late breaking today. Cool.
So that is a thing.
So there you go. Then that proves Thomas and I correct. There's a Starlink from Vandenberg on December 17th. So there you go.
And I think that is going to be 4-2. I know the last one we saw was 4-3, so that explains where 4-2 is. Cool.
Yeah, 2, not 4-2.
I think it's group 2, Jack, because the first number dictates the orbital inclination. So I think the 4s have to go out of here, and then the 2s go out of Vandenberg.
Got it. My bad.
The 2s go out of both the Cape and Vandenberg, and I'm not on comm, so you better repeat that.
Okay, so the 2s can go out of both the Cape or Vandenberg, but the 4s have to go out of here because of their inclination. Yeah.
Got it. Well, today I learned. Good question there from Grimmity? Sorry if I'm butchering your name there. Here's another one. Here's another good question from Quinn. Why a whole Falcon 9 for such a small payload? Is SpaceX...
I am on comms. Sorry, that was funny.
Oh. Well, everyone, you normally get a look behind the curtain. That's good.
Yeah, a little bit of a Wizard of Oz moment there.
But to answer the question, we touched on this a little bit earlier. A whole Falcon 9 for a 300-something kilogram payload? 325, thank you, Chris. The reason for that is because of a new maneuver that the upper stage is going to have to do. It also has to do with why the first stage has to land downrange on a drone ship versus coming back to Cape Canaveral. In order to get to an equatorial orbit, one that orbits over the equator of Earth, which, again, limits the spacecraft's exposure to the Van Allen radiation belts, which is very sensitive for this particular instrument suite. The rocket has to fly south from Florida along its mid-inclination orbit, and then once it gets to the equator, conduct a minute-long burn called a plane change maneuver to tilt the orbit back to equatorial. And so the second stage needs to have a lot of propellant on board to do that. And then the first stage has to, offer up as much of a performance as it can so that the upper stage has enough propellant left to do that maneuver. It is a very light payload, and we should expect to see Falcon 9 really jump off the pad about as quickly as it ever has compared to other missions, simply because the payload weighing it down is as light as it's ever been. But that is why an entire Falcon 9 is needed to launch it from here at the Kennedy Space Center, that plane change maneuver.
And that should really, because we do talk a little bit on streams from time to time about how expensive, from a propellant or a delta V standpoint, inclination changes are once you're in orbit, and this should really hammer it home from a mass perspective of the payload. I mean, the Falcon 9s routinely are throwing 5-6 metric ton satellites into geostationary transfer orbit, and it can only take a third of a metric ton payload to change the orbital inclination down to 0. So that should really hammer home how much of a performance to the payload these inclination changes can be, and why we don't see them very often.
Yeah, that makes a lot of sense.
Those most common equatorial missions are the ones that go to geosynchronous.
Sorry, yeah, you're catching what I realized my mistake was in that sentence.
There are actually
Yes.
lots of missions that go to equatorial, but the reason it's slightly different is a lot of the times if you go to geostationary transfer orbit, the rocket doesn't do any of that work. The spacecraft does it all. And also you're doing those maneuvers out at geostationary altitude, which is much farther away from Earth. And because of the laws of physics that I'm not going to get too into right now,
Right.
basically you are farther away from Earth when you do a plane change maneuver. It takes less energy to make that change. And so either the spacecraft will do it themselves, or in the case of the Atlas V launch we saw 2 days ago, even if the upper stage is going with those payloads all the way to geosynchronous altitude, that stage still needs a little less energy to do that plane change maneuver out there versus low Earth orbit, which is where this mission is going. So there's a lot of factors that are in play there.
Yeah.
Very cool.
The moral of the story should be play Kerbal Space Program, but you know.
Yeah, oh my gosh, and yeah, you'll understand why a plane change is just launch into the inclination.
All right,
it's also why,
more...
I mean, certain
go ahead,
missions
please.
that don't, I was just to add a little bit, some missions don't actually require a, like a specific inclination or anything. So let's say they're launching from the Kennedy Space Center, they'll just go into that 28.5-degree inclination because that's the cheapest one to get to energy-wise, is to launch into whatever inclination your launch site is at. And then you can just operate from that orbit. You'll only see missions launch anything but due east from here if they need a specific inclination to serve their orbit, whether that means they have to be able to fly over farther north and south parts of the Earth, or you're going to rendezvous with, say, the International Space Station, which, again, orbits farther north and south than 28.5 because it has to fly over Kazakhstan, among other things. So, yeah, that's another factor to consider.
Very cool. A couple more super chats coming in really quick. We are 6 minutes from launch right now, so I'm going to clear out our queue. Felix, thank you so much for the support. They say, is this launch heading south over Cuba? Nope, it's heading straight east, but you still might have a view from West Palm Beach. Mars Labs, again, with more support. Thank you, Mars Labs, for the new membership. Say, I was known as inert back in the day. I thought that was noble. What a gas. What, no rim shot? I'm so lost. Let's see.
Oh, that was phenomenal. I appreciated that.
At least you guys did. Let's see. Thank you for the support. I'm not even going to try and pronounce your name, but it's a series of letters and numbers. Welcome to Capcom. Jump into Discord when you get the invite there. And thank you to all of our new members tonight. We're getting a lot of them, which is really helpful because members help keep the lights on, keep the data paid for, and, keep the robots fed. Let's see. Josh Ritterhoff, thank you for the generous support. They say, when you're visiting the ATK rocket garden, keep an eye out for buildings that look like they have slides coming out of them. They're propellant mixing buildings. That's fascinating. I must have missed that when I was there. Good tip, and thank you for the generous support. Rough Riders, what's up, Rough Riders? Always seeing your name pop up in chat and in the membership in the Discord and whatnot. What is the most important SpaceX launch you are looking forward to in the most in 2022? I'm going to say orbital Starship. And we've got 4.5 minutes to go, so if we want to answer this one, let's keep it quick. Chris?
I mean, I agree with you, Jack. Orbital Starship test.
Psyche.
Good answer.
Julia?
I'm staying out of it.
And I see we have Stephen Marr in chat. Stephen might just be listening, but I neglected to mention him earlier, which makes me an awful person. Stephen's also out there tonight shooting photos, so we should look forward to his work as well. So, and then let's see. Last super chat for now until launch. I think we'll do is Rockwell Tory. Thank you for the support. They say back to Max Q. Did the Apollo rockets throttle down from Max Q? I believe they did, but that's a question for, I believe, Chris. Chris?
Give him a second. He's finding the mute button.
They did, yes. They
There-
the F1's throttled down. Oh, good. I can't speak now. I'm glad we're close to launch.
Hey man, it happens. You get the launch jitters. You get under 5 minutes. Your blood starts flowing. Your adrenaline starts dumping. I know how it goes.
You do. Yeah, 3.5 minutes to go until the launch of IXPE. I think this is a good time to talk about why are we actually launching IXPE? Because its name is an acronym for the Imaging X-ray Polarimetry Explorer. And basically what it's looking at is it's looking at polarized X-rays. We've never done this before in space to this degree. Only a very few polarimetry sensors have ever flown before. None to the magnitude or the degree of sensitivity that is on IXPE. And basically what this will do is it will add 2 more elements of information to X-ray observations, which will help us understand how X-rays are produced in these major objects like magnetars and black holes and neutron stars and things like that. And it's going to do this in a couple of different ways. It's going to look at the magnetic fields around these objects, which are just huge magnetic fields. And it's going to look to see exactly how polarized that light is. And that's going to tell them some very fundamental things that only polarimetry can reveal. So like the Chandra X-ray Observatory can't do this stuff. Only IXPE can. And because it's so revolutionary, it's the first of its kind. They don't actually have an object that they can calibrate it against. So the objects they choose to calibrate it with, one of them will be the Crab Nebula, IXPE is basically putting everything down for every other polarimetry experiment that will follow it. And a really massively impressive mission that's, really working with a lot of increases in technology to help us do and examine things with how the particles of X-rays are polarized, how they jitter, how they dance around, basically. And that's really going to help us understand fundamental things about X-ray production in these astronomical objects, and therefore help us understand how those objects form. And I did it with 1 minute and 14 seconds to spare.
Yeah, congratulations on that. That was succinct and descriptive at the same time. I see you're dialing in the camera ahead of launch. We've got about 1 minute to go, so... I see Thomas is dialing in the camera. I should say you will be on launch commentary for this one, which I'm going to enjoy thoroughly.
I will,
really
and I'm going to walk away from our microphone and remember to mute my microphone so you will hear me through the other one.
Excellent. Really quickly, Eric Beavers, thank you so much for the generous support, and Doug Schaefer also thank you for the support. They say no question, just happy to hear familiar voices from the space community. Love your coverage and all you do always. Thank you so much, everybody that supported the channel. About 30 seconds to go to launch of IXPE from 39A in Florida.
Indeed. So at this point, Falcon 9 is pressurized for flight. We've gotten the final go decision, and the next major event will be the ignition of the 9 Merlin 1D engines on the first stage of the Falcon 9. That ignition will come very shortly. So here we go. 8, 7, 6, 5, 4, 3, 2, 1, and lift off of the Falcon 9 with IXPE revolutionizing X-ray astronomy. and some absolute epicness, hoping that sound came across our microphone beautifully. It
Oh, it
was
did.
chest pounding out here. Falcon 9 lifting off into humid conditions, epic sound, and flying straight and true due east out of Kennedy, taking IXPE on her way to orbit. So far, so good, Jack.
Yeah, that was excellent audio as usual. You can just hear the sound of those 9 Merlin engines just tearing the air asunder as they lift Falcon 9 into orbit. Great track
That
here
is
from
an
Thomas.
excellent way to put it. Yeah, an excellent
It's what it
track.
sounds like, right? It sounds like the air is being physically torn apart. There's no other way I could describe it to the uninitiated. The sound of a rocket launch, especially when atmospheric conditions are just right, is truly indescribable. And you can see the exhaust plume expanding there as Falcon 9 ascends into lower pressure up at high altitude. It's just absolutely beautiful. Great work, Thomas.
Oh, it really is. And here we go, heading toward stage shutdown and separation here. We have shutdown of the first stage, and we are seeing the ignition of the second stage here. Yep, and we have good ignition on the second stage with the old Mark 1 eyeball.
Yep, and Thomas has got it with the camera still. Excellent work, buddy. Now, the first stage will prepare to head down and land on the drone ship, and the second stage will keep muscling IXPE into orbit.
Yes, indeed. That second stage really moving out here from what you can see on the ground. Really gaining a lot more of that horizontal acceleration. The first stage gives you the vertical acceleration to get out of the dense lower atmosphere. And then the second stage's job is really to just tip you over horizontal and just slam the accelerator on that, because we are aiming for approximately 7.6 kilometers per second as our orbital velocity target for a 600 kilometer orbit. So lots of work that second stage has to do getting that horizontal acceleration down for this mission.
Yeah, that was pretty nifty. For a few moments there before we cut to the SpaceX stream, on Thomas's feed, we could see a couple stars in frame, and it really gave sort of a sense of scale to how fast that second stage was moving at that point. It's really cooking.
It really is. It really is. And
Coming up on fairing SEP and SEP.
woohoo!
Like
And there's tiny little IXPE. Look at tiny little IXPE.
Which is bigger, Dart or IXPE? I know Dart is heavier based on what we were talking about earlier, but physically, I wonder which is a smaller spacecraft.
Dart was smaller. So IXPE fully extended, once its boom is extended, will be 5.2 meters long, 1.1 meters in diameter for the physical telescope itself, and then the solar arrays will have a diameter of 2.7 meters. So actually, this thing could have been completely unfolded inside the payload fairing of the Falcon 9 with a lot of room to spare. But
hilarious.
it still needs to be all folded up and sort of hunkered down for the stresses of liftoff, which is why there are still things to unfold and expand and deploy once we get into orbit.
That makes sense. And we are coming up on entry burn for the booster.
Woohoo!
We can see it for a brief moment there, a feed from the booster, and you can see sort of the limb of the Earth and the light of different cities at night. It was really beautiful. Thomas still tracking this thing on the left there.
And
way to go.
It is clear off to the eastern horizon, so we should be able to see the entry burn happening from the launch site as well. That entry burn happening about 530 kilometers downrange from the launch site, and we should be able to see it crystal clear here momentarily.
Fingers crossed.
Yeah, the second stage is still that little dot getting closer and closer to the horizon. But just standing
over
by
5.5 minutes from liftoff.
And again, Falcon 9 taking the Imaging X-ray Polarimetry Explorer, the IXPE X-ray Astronomy Observatory, into low Earth orbit. The initial ascent here, we're on the second stage, so this initial ascent will result in a 600-kilometer orbit, plus or minus 15 kilometers is allowable per the mission. There's entry burn. We can see the entry burn from from the launch site. Thomas looks like he's got it or is acquiring. He's got it on his camera. That is
Nice.
the entry burn of booster 1061-5 headed for just read the instructions. That burn is happening about 550 kilometers downrange from the launch site. And we are seeing it crystal clear, and it is done. So the booster headed for the drone ship there.
That was cool.
now-
There's a very, very barely illuminated bird sitting on one of the pilings in that shot. What a cool shot.
That
And
would be
just-
our resident unimpressed pelican. Yes.
Nice. Just goes to show, I mean, how big Falcon 9 is, that despite being, what did you say, 500 kilometers downrange, we could still see it on a clear night like that.
Yep.
And so that entry burn shielded the booster from the heat of re-entry. So now it gets to coast a little bit longer, and at the same time as it's landing, roughly, the second stage engine will shut off for the first time. Right, Chris?
Yeah, so normally, yes. On this one, a little bit different. The Falcon 9 will be in orbit less than 50 seconds from now. So we will actually complete the ascent to orbit on the second stage before the landing burn begins on the first stage for this particular one, because IXPE is so light of a payload.
Nice.
Falcon 9 can get into its initial orbit much quicker. And speaking of which, with about 30 seconds of powered flight remaining, so the initial orbit is 600 kilometers plus or minus 15 kilometers is allowable at 28.5 degrees inclination. We will then have a roughly 20-minute coast. It's like 20 minutes, 47 seconds. Down to the equator, as just the orbital trajectory takes you down to the equator off of Africa. And that's when we will then have the reignition of the second stage, not to change the orbital apogee or perigee, but to change the inclination only from 28.5 degrees down to 0. And we see the shutoff and shutdown of the Merlin vac engine there. And we see the landing burn starting. Look at that.
Whole lot of pixels coming through on SpaceX's feed. Let's see if they keep drone chip signal. So far, so good.
I see a flame.
I see pixels.
I see flame out.
And it landed.
I see a booster. Yeah. So that is 1060. That is 1061-6. Now sitting on the drone ship. The boosters level up upon landing. So that is now 1061-6, sitting on just to read the instructions, and it'll be brought back for another mission now. And meanwhile, a new shot of the second stage engine as we are in our approximately 20-minute coast across the Atlantic now.
Very cool. I always love those nighttime drone ship landings where you see the ocean lit up blue by Falcon's exhaust. But what I love even more is this view that we have right here, which is what we always want to see on launch day, which is a launch pad without a rocket, because the rocket has done its job and flown.
Precisamundo. Yes.
Very cool stuff. And there is the spacecraft very briefly on top of the second stage. There's a second stage engine. You said 20-minute coast phase?
Yep, just over 20 minutes to coast down to the proper point in the orbit where they will do the burn. Not quite exactly over the equator. You kind of time it so that you've finished changing your inclination when you reach 0. So, or in this case, 0.2 degrees, which is what they're aiming for. And there is and as well as the plus or minus 15 kilometers that's allowable in the orbit for where Falcon 9 will drop IXPE off in, they are also allowed to be within 0.2 degrees inclination of the target. So they could wind up at either true 0 or 0.4. And that would be fine for the mission in terms of meeting the parameters for the liftoff.
Very cool. I don't know how soon you guys are going to have to pack up, but I've got a couple more questions I can ask.
We actually do not, because we are on the Kennedy Space Center side, so no one's going to run us off.
Nice. Well, we already explained the plane change. That was a good question we had in the queue. Sorry, what were you going to say?
Oh, no, sorry. There was just a pause. I was saying ask away.
Well, since we just had the second stage shut off its engine, here's a relevant question from Kieran asking, does Falcon 9 upper stage need to perform an ullage burn of some kind before firing up the MVAC? We often hear a lot about ullage with regards to some other rockets, but not others.
Yes, it does. Yeah, so there are tiny thrusters on Falcon 9's second stage that will fire to produce that ullage to basically push the propellants down into the tanks to create a stable ignition, a stable propellant flow for ignition of the engine.
Yeah, ullage is basically, if you guys don't know, just a fancy way of saying settling the propellant to the point in the tanks that, you know, with gravity would be the bottom, but in zero gravity, without some force, it's just going to sort of float aimlessly around the tank, which you don't want, because you don't want an engine to be running and be propellant starved. That would be bad for the engine, probably resulting in, you know, ruds.
Oh, not probably.
You're gonna have a bad time, basically, if you run exhausted on propellant. That's why, you know, that's why they need burns like that, or control thruster maneuvers, or whatever you want to call it. But yes, to answer your question, Kieran, yes, it does. I hear you yawning. I know it's early
I
up
know,
there.
sorry.
It's the launch adrenaline wears off at just about T plus 10 minutes, Jack. You got
Pretty much it, yeah.
Yep. Oh, I've been driving home from a launch site late at night and suddenly become very tired because my body decided it had burnt through its allotment of of adrenaline there. Dougal, thank you for the super chat. They say excellent shots tonight. Thanks, y'all. Thank you, Dougal, for everything that you do and all of your support. Long-time supporter there. Sean O'Brien, also thank you for the support. They say, what causes the pulsating of the foil above the engine on the second stage?
I'm pretty sure that is a result of the RCS thrusters we were talking about a little bit earlier. Just as the upper stage is going through its burn and making very small attitude adjustments, when those RCS thrusters do fire, I believe that just causes a little bit of a vibration on the foil. That is what I'm pretty sure what we see when that happens.
Very cool. Really quickly, Captain Kevin, thanks for the support. They say, I love the stream. It's top-notch every time. Thank you, Captain Kevin. And Clint Thompson, thank you for the support there. Thanks to everybody, all of our new members on this one, all of our current members, and everyone that's super chatted. Hey, if you want, I'm going to hate myself, but if you want, hit the like button. And if you don't subscribe, subscribe. Let's see, CA&P Railroad, thanks for the support. They say, just curious, how long does it take a second stage to deorbit? That varies, right?
It does. In a low Earth orbit, if we're talking about an actual deorbit burn, those burns take only a couple seconds. It does not take a lot of energy to drop out of low Earth orbit. If we're talking about passively deorbiting, where the stage just naturally decays due to drag in low Earth orbit, that varies depending on the altitude pretty significantly, but in the 400-kilometer range, that would last less than a year, I believe, before re-entry. And again, it also varies based on what the upper stage is, how big it is, things like that. But at low Earth orbits, the upper stage also decays relatively quickly.
And that's if the second stage were to fail to reignite. This particular mission will do a deorbit burn and come back in over the Pacific, which, what Thomas was saying, that also varies from mission to mission as to how long it is. In this case, I think it's within a couple of hours of payload separation is when the stage will re-enter over the western Pacific Ocean.
Very cool. Remy Turk, thank you for the support there. Let's see. So we're going to be waiting here for deploy. We got a little ways to go, but we're making good progress.
You can see it's getting closer to Africa.
Yep, sure enough. It's got to sort of cut across the limb of Africa there and get closer to the equator before it does its burn, right?
Indeed. And that burn will be timed for about a minute before the orbital path brings them directly over the equator, because it will take about a minute to do the actual burn to change the inclination, and you basically to change the inclination, just as when you're launching, you can only go as low as the latitude that you launch from. Well, when you try to do an inclination change in orbit, you can only go as low as the inclination that you are at the latitude that you are currently at. So they need to finish the burn down to 0 right when they cross 0 to get it right there. So that's what they're going to time it for on this particular event.
Makes sense. Here's a question Julia might know the answer to. Could we see 2 boosters in port at the same time?
That is always a possibility, but my guess is that the booster that is currently in port will have already probably been transported to base before 61 gets back. It has
would make
happened
sense.
twice, though. Yeah, has happened twice. Although there isn't necessarily that immediate need to, get right on it and process that booster, and it can sit there for 24 hours in port before they really do anything with it. Chances are it'll be gone so that they can just make room for the next one to come in.
We're looking at Fleet Cam right now, and it looks like it has the sort of lifting cap leg retract mechanism attached to it. Is that the case?
If it has green lights at the top, that would indeed be the cap on top.
I see green lights, so I see a cap on top. So come daylight, they will probably be able to proceed into recovery operations with that booster fairly quickly, given that the cap is already installed.
That's right. Just got to lift those 4 legs, put it horizontal onto a transporter, and off she goes.
Much like me when I'm on the way to I don't know, bad jokes. Let's see. Nathan Green, thank you so much for the support. They say, love the coverage. Any predictions on how many Falcon 9s will fly in 2022?
Not one, considering we didn't come close to the prediction of 2021, because it's all based on how many Starlinks they're going to end up launching and how many batches of Starlinks will be ready. Because if you look at the first part of this year, right, they were aiming for 48 Falcon 9s in 2021, and if you look at the first part of the year, they were basically on track to do that because they got to the end of June with like 22, 23 flights to their credit, and then everything just came to a screeching halt because either their paying payload customers were not ready, as was the case with some of the Air Force or Space Force missions that came up, but also the Starlinks just sort of stopped being ready, and their cadence went down, and we're at what, 20? What was
This
today?
was 28th, I believe.
This was 28. So I mean, they missed the target by about 20 this year because the Starlinks weren't ready. So it's going to come down to the Starlinks next year as well.
Yeah, it was rather feast or famine around here, and it was very, 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 very quiet in the middle of the year. So
there was also a LOX shortage too, wasn't there?
Yep.
Which I think what we ended up with here is that ended up not being an issue. It was something they were tracking and sort of getting prepared for. ULA ran into it a little bit more than SpaceX, but none of them actually ended up not being able to go because of the LOX shortage because of COVID treatments. We managed to just barely eke by that, but India got hit particularly hard with that and wasn't able to launch because of the LOX shortage. LOX being liquid oxygen.
Nope, it's smoked salmon. It's delicious on days.
Now I want a bagel.
I've made that joke 1,000 times. People are probably sick of it, but I don't care. I love me a fishy bagel. Let's see. Greg, thank you for the support. They say, great broadcast. Keep up the great work. We will with your support, Greg. Thank you. Clint Thompson again with more support, saying, speaking of that rocket garden, Northrop Grumman graciously allowed my high school students to launch a high-altitude balloon from there last year. That is very cool.
Ooh, sweet.
I want to be in your class. Robbie Bradley, thank you for the support. They say, hey, y'all, listening to y'all. We've got 2 y'alls in this one. Excellent. Listening to y'all on my way home from work. Great stream as always. My question is, what are your thoughts on the Falcon 9 booster going through the Rocket Garden at KSC earlier this week? We've got Rocket Garden questions and comments galore today. What are your thoughts on the Falcon 9 going through the Rocket Garden at KSC earlier this week? Go.
I loved it. It was a little bit earlier than this week. They hauled it over there a couple months ago. I think we got a picture of what it's sort of going to look like in its exhibit this week. But yeah, no, this was a long time coming because SpaceX sort of said this booster is the visitor center if they wanted it, and then we just weren't hearing anything, and then this mysterious structure started to go up. They sort of cordoned off an area, they started construction, and that's where it ended up going. So it's kind of like the Atlantis exhibit in that it's indoors. It's not actually outside with the other rockets in the garden. So very akin to Atlantis in that regard. But it's there, and I'm all for that because, yeah, that's a huge part of the story, right? And as you walk through the visitor center here at Kennedy, you want to get that full story of like, this is the rocket that launched, our very first satellite from the U.S. These are the crew rockets, these are the shuttles, and now here's the next generation for reusability. Nice to see it, and I think it's going to be a good exhibit once it's ready to be opened.
Do we know which booster it is?
Isn't it a Falcon Heavy side booster, perhaps? I think the one they had on display when they had the National Space Council.
It may be that one.
So,
Yeah.
so it's one from the Falcon Heavy demo then, the very
think
first
so.
one.
Yeah.
I think.
Which both of those flew as Falcon 9s prior to that mission. So that booster would be twice flown, once as a Falcon 9 on the side of a Falcon.
Thomas, you know what we saw today?
The opposite of that.
I know we saw. Isn't this a first? We saw 1052, but guess what? It wasn't a Falcon Heavy side booster anymore.
Because it had an interstage on it. Yeah, we saw a formerly known as Falcon Heavy side booster. It flew both Arabsat and STP-2, and it was rolling past the press site earlier today with a second stage attached to it and an interstage, and it is back with a vengeance for a Falcon 9 launch now.
Well, they finally did it because, dang, we were waiting for that moment. I mean,
and what a moment it was.
Yeah.
Well, especially last year when they were running into like manifest crunches, when they lost a couple of boosters when they were headed for the drone ships for recovery. And we kept saying, like, well, they've got these two Falcon Heavy side cores. They keep saying it's just a matter of slapping an interstage on them. And we finally saw it. Yes, good.
I remember seeing many an angry nerd vociferously debate on places like Reddit and whatnot, like, oh, they're never going to actually convert them, they're way too different. And so here we are.
I mean, to be fair, I was starting to have doubts simply because it took them so long, but it sounds like they have brought them back.
I'm going to put something out there, like, maybe, just maybe, that might be the next Falcon we see fly, maybe?
It might be.
Because the lights are on at Launch Complex 40, and that's not exactly normal.
Well, that was almost, I think I know what you're going with this, Julia. That was almost certainly the Turksat 5B booster for the flight on the 18th. Yeah.
Oh, nifty that.
And that would be the Inspiration 4 booster, whose number I'm forgetting, even though I literally talked about this like less than an hour ago. Whatever booster that is probably for CRS-24. But neither of those are actually confirmed. Because I believe that is the next booster in line.
Yeah. Of course. Could be the other Falcon Heavy
or
side
the other.
booster.
Oh, there you go. There's an idea.
I tell you, they really missed an opportunity not launching Turksat on Thanksgiving. All right, I'm fired. Thank you for. Let's see.
I love you, Jack.
We're talking about swapping a Falcon 9 with a Falcon Heavy side booster and vice versa, and we have a question about it from 60 minutes ago. BC Battlegrounds, thank you for asking the question here. What are the changes a booster needs to go through from Falcon 9 to Falcon Heavy?
That direction? Oh.
I mean, it needs an interstage versus a nose cone, right?
Well, wait.
We don't have to go necessarily in the exact direction of the question, but really, what are the differences if you're going to swap one with the other, or you're going to turn one into the other? What do you need? What needs to be done?
So the last that Elon said was basically this. You can take a Falcon 9 that is configured as a Falcon 9, like what we just saw launch today. And it's just a matter of taking the interstage off, putting a nose cone on instead, and then attaching the actual like attach hardware where the physical attach points between the core stage and the side boosters would go. We are seeing the second stage getting ready to reignite there. 28 something is the reignition on that. But basically what he said is it's basically simple like that to convert it from a Falcon 9 to a Falcon Heavy side core. basically the reverse of converting them back. This is what Elon said. He probably oversimplified it. They probably had to do a few other things. What you can't do is take a regular Falcon 9 and make it a Falcon Heavy center core, because those require a whole bunch of different they're manufactured slightly differently. They have to be beefed up in different ways and at different points to handle the thrust that's literally coming through the attach points, because the center core has to handle all of that from the side cores. So it's basically a Falcon Heavy center core could be a Falcon 9 on its own, though they probably would never do that and just reserve them.
It would actually be like, it would have a higher dry mass because of the. I mean, I don't know
Right.
how significantly higher, but you would have a little bit of extra weight for that. The other change that they might be making, especially after the most recent flights, is changes to the thermal protection system, because the center cores separate with so much more downrange velocity that they come down with a lot more thermal energy to dissipate. And we saw that for STP 2, because that booster failed due to a heat shield failure, because it was trying to land like 1,200 kilometers downrange or something stupid. So, that might be something to also change on center core boosters.
Yeah.
We just saw a huge chunk of ice liberate from the second stage there. That's totally normal. I'm sure we'll get some questions about it in chat.
Yep.
It's not a UFO.
Normal.
It's ice as it sublimates. Big fancy way of
It's in
saying
the-
it just goes from ice to gas and skips the liquid phase altogether.
Sure enough. Let's see. Mike Astronaut Siru, thank you for the support. They say missing DOS art to explain that orbital inclination change. That would have been a good one. DOS is a busy guy right now, though, and we thank him for all of his hard work. There's good reason he's not on the stream. We'll put it that way. Randomly TVly, or Random TVly 3. Your name is a challenge, my friend. Say, could someone in Africa with a good camera spot stage 2 or other Cape Canaveral launches?
They could. I want to take a moment, though. Look at what is on your screen right now. You see that little... it moved.
Right as you mentioned it, of course.
Man, that gray line that just kind of goes perpendicular all of a sudden to the blue line going like, nope, I'm out of here. That's the inclination change. Like, that's how impressive it is. So if they put that back, watch for it. But here we go, coming up very, very soon on the reignition of that second stage to do the inclination change maneuver from 28.5 degrees down to 0.2 is our target. There it is. You see that gray line just going yeet right across Africa there. That is the plane change. So that gray line is what the stage will follow after it does its burn. The blue line is what the stage would follow if it, for some reason, did not reignite its engine.
We do know
Blue
that
line
all
bad,
rockets are
gray
actually
line good.
just
Got it.
heaters. That's the real word. We get it.
Yes.
Up and here we go.
Second engine startup.
And again, this is about a minute-long burn to make this inclination change.
Yeah.
Looking good as that nozzle heats up to red hot.
Mm-hmm.
It's a niobium nozzle, right?
I believe so, yes, right?
You said it pretty confidently, Jack, so I'll take your word for it.
And I want to point something out, too. The velocity is going down, which is exactly what you would expect when you start to do a plane change maneuver like this. So part of the way that you do plane change maneuvers is it does start to... The first part of it will start to alter your orbital perigee just a little bit, lowering that down, or apogee. And then on the back half of your burn, you're going to re-put the apogee and perigee where you want them to be. But that's just a function of how you have to do these plane change maneuvers. So the fact that velocity went down at first and is now going back up is exactly what we were seeing with that expected change. And that should be cut off.
Too.
And look at that blue line now. Blue line good now. So that was that really expensive change. And look at that, 600 kilometers bang on the number. So they got well within the 600 plus or minus 15 kilometers for the orbital altitude target they were going for. And now we wait about 3 more minutes for IXPE separation from the top of the Falcon 9.
Talking about precise orbital insertion, right, Chris?
Indeed, or at least as precise as you can get. Which is why there's always some wiggle room. You know, why would IXPE be 600 plus or minus 15 kilometers? Well, because your second stage engine might not have the best day that it can possibly have, and it might leave you in a 558 instead of a 600. So there's always a range that you can get into with these particular missions. And I love that the forward-facing Falcon 9 payload cam XP is so small it's barely
It's so
on
small. It's like,
camera.
wait, where is it?
Yeah.
Now, we were talking about the smallest payloads that SpaceX has ever launched, and we determined that DART was slightly smaller physically than XPE. What about TESS? Because TESS was also ridiculously tiny.
So, in its folded up configuration for launch, I don't know. All I know is that when they deploy, the physical instrument is a bit bigger than DART.
Okay.
Bigger than I think it's bigger than TESS. I'll have to double check. I think we're like oh, my brain. What's the satellite you literally just said?
TESS.
TESS. Thank you. Jesus. I think it comes down to like when their solar arrays are deployed.
Sure.
They can sometimes like DART can be bigger than it because of solar arrays, but I think just compact folded up. I think this is the smallest.
And I guess I should preface this because I actually misspoke. It's definitely not the smallest payload SpaceX has ever launched, because SpaceX has also launched CubeSats. I'm talking about dedicated mission with only one spacecraft on board. I should specify. Obviously, CubeSats are even smaller, but I think chat knew what I meant.
Somebody say CubeSat? Do I get to talk about CoolSat again?
There you go.
We're gonna get CoolSat launched, Jack. We're gonna get that happen for you.
Thanks. In the same vein, as we're waiting on deploy, which should be coming up here shortly, we do have a question about the lightest and heaviest payloads Falcon 9 has launched.
The heaviest is the Starlink stacks, right?
Yes.
Or did Crew Dragon get heavier?
I believe the Starlinks are heavier. Yeah.
When it's a full stack of 60 during the
Right.
phase 1 launches, those were the heaviest.
So, question, Thomas. Would I be wrong in saying that I believe that Starlink launches are heavier because those boosters seem to get yeeted and scorched a little bit more than other missions?
That could be part of it, although that's more of a function of downrange speed. Like, how much speed does that booster have when coming back down? Which that prize goes to those Falcon Heavy center cores. Well, all right, that's kind of cheating though. There were Falcon 9 flights that I think land farther downrange than Starlink, but I don't know. I'd have to check. But it is
a few of them have.
demanding.
And there we have it. We have spacecraft deploy. Look at it go.
Yay!
There she goes. Go XP, go.
What a cute little.
And there goes there we go. There go part of the deployment sequence already. Remember how we talked a little earlier about how it has to get power positive very, very, very quick, and that dictated our night launch so that it's in daylight when it comes off the top of the Falcon 9. First thing we always do is deploy our solar arrays and communication antennas. So yeah, look at XP go.
That's an awesome shot. That camera's on the top of the Falcon 9's second stage, and I think that's the coolest payload step shot we've gotten from one of these.
It's a really cool one. It also kind of makes me a little bit wistful. Like, I want to hug something. Like, goodbye, little payload. We love you.
Safe travels.
Yeah. So really quick, before we wrap up here, what is next for IXPE? It has a 30-day commissioning phase, of which several of those are rest days where they won't do anything, but they're available just in case. First up and foremost today is getting the solar panels out, getting the communication antennas up and running, making sure you have a power positive and healthy spacecraft. Then they will go into about 7 days after launch boom deployment. So the big boom with the 3 telescopes on the end of it has to deploy for full.
Solar arrays deployed. Sorry.
Cool. And solar array deployment confirmed. So that is fantastic. That commissioning phase starting off with a good thing. But then after they get the boom properly deployed, they'll align the telescopes properly based on boom deployment, and then they will go in and start to calibrate the instruments. And they'll pick their target to calibrate. The Crab Nebula is one of them. And then after about 30 days, IXPE will be declared fully up and operational and ready to look at those polarized X-ray particles that are coming from some of the universe's more impressive and terrifying things. Magnetars are terrifying. Like, just for the magnetic fields that they have, they're terrifying.
It may sound like a Pokemon name, but it is anything but cuddly and fun. They
Yeah.
are in fact terrifying.
And if you don't know what we're talking about, that's the Google rabbit hole that you can now go down at the conclusion of this broadcast, is how terrifying magnetars are.
One of
Not to
the
be confused with
many
Magmar.
exotic.
Yes.
Sorry,
yes,
say that again,
indeed.
Julia?
I was going to say one of the many exotic places that IXPE will be exploring.
Yes.
Yes, indeed. But I think with IXPE in orbit and solar arrays deployed, and with our quintessential happy empty launch pad view, I think we're good. I think that's it for IXPE. Congratulations to SpaceX, to NASA, to the Italian Space Agency, and to all the scientists who have worked on IXPE. It's going to be an incredible 2-year mission to see what that little explorer gives us that Chandra cannot.
Indeed. Thank you, little spacecraft. Well, really quickly, before we go around the horn here and wrap everything up, I just want to say thank you, Ego Ekis, for the support. And Matt, thank you for the support. Thank you to everybody. Thank you to all our new members on the stream. We had several new members coming through. Really appreciate y'all and everything that you do for the channel, helping us to sort of get that more consistent revenue stream and able to plan things out and keep the lights on, keep the robots fed. It's really invaluable. So thank you to all of our new members. We hope you enjoy your member perks, the chat emoji, the preview videos, the Discord access, wherever it is that you came in at. Thank you so much. And yeah, I think with that, I will go around the horn. And Chris Gebhardt was out there in the field providing launch commentary, assistant managing editor of NASASpaceflight.com, and launch reporter extraordinaire. Thank you for the commentary tonight, Chris.
My absolute pleasure. Would not have been anywhere else. Happy to see IXPE on our way.
Yeah, that was a cool launch. And then next up, we've got Julia, who was out there in the field. Julia, thank you again for being on Launch Comms.
Why, thank you for having me. Stephen is not on Launch Comms, but he has pictures, some pretty awesome ones to share with you. My out of comfort zone picture did not work, but we will have remotes coming up. So thanks for joining us. My next mission is to do mission accomplished patches for our crew.
Nice. Make sure you follow Julia and Chris on Twitter, and also give Steven a follow, and be sure to keep an eye out for the excellent photos that he has either already posted or will be posting shortly of tonight's launch. You can see there his Twitter handles at SpaceCoastSteve, and also out in the field. Tonight was the excellent tracking Thomas Berghardt. Great track tonight, Thomas.
Thank you, Jack. Oh, it felt good to track a launch again, and always good to see a new scientific explorer out there to start its mission. So thanks everybody for watching, and everyone here in the field really appreciates everyone's support, and glad you enjoyed the launch.
Indeed, that was an excellent launch and a great sounding one as always, so thank you for that. Michael and Baylor in the background, you might have heard him a little bit earlier. Michael, thank you for pulling the levers, pushing the buttons. Got your little card up there. Next Spaceflight, providing an excellent resource to everybody in the spaceflight community. Check out the Next Spaceflight app if you are so inclined. If you're wondering when things are going to happen, if you want a good app to keep track of things, Next Spaceflight. And the developer of that is our very own Michael Baylor. And I, the guy flapping his gums right now, am Jack Beyer, photographer, video editor, video producer, whatever you want to call me, live stream host extraordinaire. I don't know if I'm extraordinaire. I'm just regular. But either way,
I'll give you the extraordinaire, Jack. You're an extraordinaire.
excellent. If you're going to give it to me, I'll take it. Thank you so much. Thank you so much, everybody, for watching tonight. And with that, we will see you all next time.
We have liftoff. Propulsion continues to be nominal.
Our chamber pressure looks good. Following up. Roger, roll, Atlantic.
Water towers, fly! Yes!
Tango Delta nominal.
Fighting down speed off. Bring in, speed off. Off. Yikes. You bet. Concur. We don't need any more of these.